Hello! Today is February 25th, 2017. I'm Danny Blanchard. This is my hobby room, and I want to show you my latest and greatest addition. That is the ShapeOko 2 CNC machine. I got this off of an online forum, found a tip from a guy that said he was looking to get rid of this thing for a screaming deal. A whopping $200 plus about a tank of gas to drive out and back to the far Chicago suburbs, out in some beautiful fields that I wish I could have seen because it was really dark. Anywho, I picked up this machine, great deal. It's about, I don't know, a $1,500 machine, $1,200 to $1,500 in there just as I got it. I paid $200 for it and that made me very happy. But I've got a couple things I want to do to it this weekend. I've been tweaking and tuning it, putting things together for the last week and a half. And when I say a week and a half, I'm working 55 hours a week, 6 days a week, and I don't really have a lot of free time. So, you know, an hour maybe every couple of days that I'll throw into this thing. But this weekend, I've been able to play with it a little bit more, and my hopes are to do two things. One is work holding. So I've got this Mic 6 cast aluminum, machined flat, beautiful plate that makes for a great rigid work surface, but I don't have any holes in it to put bolts in to clamp my work pieces down. So whether it be plastic or aluminum or steel or bronze or brass or plastic, if I already said that, whatever I'm going to clamp down, I need to do it tightly and securely. So I'm going to put in probably 1/4 bolt holes, and then I'm also going to drill and ream some 251 holes for dowel pins. And when I say 251, I mean 0.251 inches or 1/1000th of an inch larger than a 1/4 inch. And the reason there is that's for a dowel pin. And dowel pins are, you know, if you get a really precise one, exactly 250 or a 1/4 inch in diameter. And by reaming it out, opening that hole to 1/1000th of an inch larger, it allows for what's called a slip fit of a dowel pin into that hole. So the idea is that I'll be able to slip fit these dowel pins vertically into the work surface, and then I can butt my material up against those pins and then clamp it down using the bolt holes. So that way I get squareness to the gantry of the machine with the dowel pins, and then I get that clamping force of the clamps. So that's project number one. Project number two is to get limit switches installed on this for all the axes so that it can't over travel and smash itself in either X, Y, or Z into itself if I mistakenly say, hey, go too far, or go, well, really just too far in any direction. And it also allows, by having those electronic switches, for the machine to move to a position that we call our home position, or its zero origin, where it says, this is my XYZ 0 point, and then from that it extrapolates all the distances. So when you send it code, the computer program will say all of its moves, you know, one little step at a time, are all relative to that 0 point. So that way, if I have to replace a tool, or maybe a tool breaks, or, you know, the power goes out or something like that, I can turn the machine back on, hit home, like a homing cycle. It will move to all the different axes, touch those electronic switches, and it knows exactly where its position is once it's hit all those, and it resets its 0 position. So then I can resend the machining program, and it cuts the same exact thing that was cutting prior to the tool break or the power outage or whatever happens. So those two things I feel are pretty important in any CNC machine. So that's what I'm going to be working on. I have this old electronics kit from Radio Shack that I got years ago because I wanted to get into Arduinos and coding little things. And they happen to have some resistors, so I'm going to use these as pull-up resistors. These are 1 kilo ohm resistors, and then it also had some ceramic capacitors. I believe these are like 1 picofarad or nanofarad, or there's something. And those will work in conjunction with the limit switches to filter out noise, ambient noise, because the spindle motor is quite noisy in the RF sense. So anywho, enough of me talking. We should watch this thing move, because that's always exciting. So I've already jogged it from the back, which is going to be its home position, to the front. And now I'm going to just hit a return to home. So here we go. Ta-da! Anywho, that's all. Thanks for watching, and see you next time.